Hi again, everybody. I just wanted to make a really quick follow-up video of C exceptions implementation part 1, uh, where I've seen at the end of the video that there is no mention of try and catch, which is absolutely essential to the implementation of any kind of exceptions or any kind of implementation of exceptions in every language. And I just wanted to make a quick follow-up video or a follow-up um, implementation where we covered that as well. So just to give you some context and background of what we did in the previous video titled C exceptions implementation part 1, is that we were using quicksort recursion in order to put great emphasis on trying to return an exception from a nested call function where you gotta go all the way back or return your way all the way back to the initial call origin. And this is how you have to stop that call at that point of time. For example, if we throw an exception in this call, we will not execute any instructions from the very next line on. So you gotta make sure to catch your flag if it's true and return that call itself. So as you can see here, I have made some modifications to the code, but before we get to that, there's something that I wanted to cover, and that is the breakdown of what we did in the previous video. So in the previous video, we have broken down this implementation of exceptions in C in comparison with C++ exceptions in C++. So C++ handles this case where no exceptions are thrown whatsoever, and the modern compilers optimize it in such a way that we have zero overhead runtime cost if no exceptions are thrown. So, and I really don't know how to approach that at this point of time. That's why I named this series as C exceptions implementation, but only part 1, as I will try to figure out on the fly and on the go how we need to or how we implement a case where there are no exceptions thrown whatsoever, and why would we need to be penalized for implementing such an approach, but we are all the same penalized here because if there are no exceptions thrown, we will have to go through our conditional jumps or conditional checks. Anyway, in that video, in order to dot Orval I's and cross Orval RT's, we made sure to return from the nested scope and have this sort of quicksort example. I've also included this example where there is no complicated code logic, but rather than it's just throwing an exception from the initial F1 call, where we have a nested structure where F3 calls F2 and F2 calls F1. So we are in itself creating a structure, and we also have to make sure that these are not inlined so that we don't create like a mirror structure or infinite, not infinite mirror structure, because we have a base call here, but it would just keep on nesting. But even if you let your compiler inline, in that case, it will just function and it will behave the same as if we called our function. But then I'm not sure if we are going to use our stack trace if we're using something like backtrace, which is a Linux specific function for C. But that's neither here nor there. Let's get into the ins and outs of this one here. So what we left behind in the previous video is, and we left out, is how do I simply catch my exception in a piece of code or in my current code block. So because we're already doing if here, that if simply works as our, or behaves as our catch block. While in this case, because we're not throwing anything, this is not needed. But let's just say that we are throwing something. And also I wanted to cover a scenario where I'm returning something from my function. Since we've covered the quicksort, which is a void returning function. But this one is, we are returning something out of it. And if you're returning something out of it because our value is a union, you cannot possibly throw something like this. Because in order for a union to work, you have to keep track of your current active member. And if you are not, once you catch your exception here and our flag serves as a catch block, you will not get anything. Because our active member is now return value. So if you're throwing something out of your function, you will never define a return value. If you are returning, if you are just returning something, you can do something like this, right? And we will get to a point where I forgot to modify this code. I will say F3 returned. And since we're returning an integer out of it, let's go with a value dot return value. Now, of course, this is just it's bad naming, but it's bad naming convention. But I'll let you be the judge of that and change it. Okay, I also need to change this. Let me just verify it. This is 10. It is. Alright, so that is our catch block. So each time you see a true in here, we're treating this as a catch block. So let's say I wanted to catch my exception here and return another value. So let's say I'm throwing something out of my initial F1 that builds up this nested structure of calls, and then I would like to return anything or an int out of my function. So this will be F2 return, and I will set my error flag or my exception flag to false. And obviously this is bad naming convention, but I'll let you be the judge and decide what you want to name it. Value dot return value will, let's say, will be 33. So now there will be no exceptions thrown out of the F3 because we caught our exception at the F2 function level, and we turned 33 from there, and that is 33 for us. Make no mistake about it. And that's how we catch our recursion. And if we want to rethrow a different exception, oh, actually, I will name this F2 exception. And if we, or actually the exception message in here is just obsolete and redundant at the same time, because our active member of the union, since we're not throwing anything, is the return value itself. But if we want to rethrow something, I will name that F2 and I will set this to true. And this is also the point where you would potentially build up your stack trace via backtrace or whatever implementation you have. There is one implementation that's kind of nightmare for your code base, but each time you would call your function, you would create a macro wrapper where you say call function, and then since there'll be a multi-line, you have your arguments here. You'd probably use var, I can't remember how to do this, sorry, but it will be a multi-line where I'm pushing my call name. I don't know, it's gonna be a line or something, yeah. And then you will make your function call, and this is my function, right? Function, arguments, and then you would pop somewhere here. And then at that point, within that function, you will be able to access your respective stack that you are using to sort of simulate the typical stack on the assembly level. But then you're ending up with a lot of overheads. Not only do you have to deal with the call overhead of assembly, where we have push, pop, and return, but now you have to deal with your own call stack trace. But this macro would be probably useful in cases where you're debugging your code, where if you're using the same macro in production, your macro would just be a typical function call like this. So bar, and you would just do this. And this would depend on your ifdef debug, on your macro flag, where you say else this is going to be my function call. But anyway, that's neither here nor there. It's kind of relevant to what we are doing here, but it's not entirely, it's notable, let's say. And one other sort of handicap of the variant value is that you need to create a separate return, or actually variant value, for each of your respective function calls from which you're either you're throwing an exception, or actually you will be forced to throw an exception if you're using variant value. Well, not forced, but if your function throws something or might throw something, you will use a variant value. Now, we could be using some approaches of may turn or may throw or something like that, but that's not. I don't know. It's not feasible. If you're, it's almost like a keyword that we have specified in our implementation, where if I define my function, and let's say I'm using a blank macro, just so that while I'm reading my code, I can determine whether or not my function throws. And if I define a macro like this, I will be certain whether or not my function throws. And if that macro is not defined in my function definition, or we can make it part of the function declaration if you're looking up the declaration and looking at the type signature at the same time, so that your code is more readable and understandable. What is this? Function definition for F1 is not found. How is that? Pretty sure I'd find it here. And that's strange. Maybe my Visual Studio hasn't read that, or maybe it expects a throw in here, but I doubt that. Oh, it does. Well, that's interesting. I thought that wouldn't necessarily be required, because this macro is just for readability purposes. It's just nothing other than an optical illusion, just to make our code base more readable. But yeah, that would be what we cover. And just to wrap it up, essentially a catch block. And I thought that this was self-explanatory in the previous video, but you know, these kind of things are really subtle, and it's really easy to get stuff wrong. As Linus says, you know, C programming language is simple, but just for that reason, it is quite easy to get stuff wrong in such a simple language. And since we already have our catch block and this is being treated as our catch block, that's how you would handle this typical scenario. And so I'm throwing here, so this is it. This is the catch block. And we might, as far as to define a, but you might be wondering, okay, is this a finally block? No, it's not a finally block. It is something, it is almost like a try block, because now we have successfully returned from our initial function. So value f3, and this is where you would, now it's kind of, it's confusing to look at it because we flipped the order, but at the same time it's not, because it's logical and it's self-explanatory. Okay, if I return something from a function, if I return an exception from my function, or if it's thrown, I would do something in this block. So do something in the catch block, because by default we have accidentally, I would say, built a catch block itself by itself. So now this is try for us, and if that goes as if that goes successfully, you would just return from it. So yeah, and let me just finish the thought and put the finishing touches. We can create our catch block where we say v if v dot error flag equals to true, I kind of hate multi-line macros, but yeah. Catch, actually catch will just be if, because I don't want to like provide my code block as a parameter. It's just very, very difficult to read. So I would do catch value, and then I would do this, and actually we can do try and put it here. It's weird, but we can. And your try would be try, it will be just else, I guess. Yeah, I always forget to put in define in there. And yeah, that is our macro implementation for our C exceptions implementation. All right, that would be all for this video. I hope you enjoyed it and you find this useful, and also make sure to check out the C exceptions implementation part 1 to have enough context and enough background before you brush up on this video. Or actually, let's just brush up on the previous video and get to this one, but without just jumping straight to this one. All right, that would be all. Thank you for watching and take care.